Hey, this is Mr. Gagnon again, and we're going to give you a little bit of a recap on vectors and bearings. So, in real life, um, things exist, not in just one dimension, but we've got 2 and 3 dimensions. Again, I said in this class we're going to be taking a peek at both x and y dimensions and not really getting into the z dimension. So we need to have a way to express a vector magnitude with the direction. So I will give you the way to do this. We're going to take a peek at the coordinate plane, the x and y coordinate plane, and what we're going to do is label it. Okay, so this would be the north, this would be the south, this would be the east, and this would be the west. And how we express vectors, okay, would be something like this. So let's say I had 3 vectors here. Let's say we had 2 meters north, and then we had 8 meters south. Okay, that's one vector. That's another vector. Let's say we had 4 meters 20 degrees north of west. Let's say we had 6 meters 35 degrees north of east. And let's put one more in there, 7 meters 25 degrees south of west. Now, this is new to you guys. We're going to know that this represents north of west. Okay, north of west, north of east, south of west. And how we really want to express that is like north of the west line. So here's the west line, here's the south line, here's the north line, here's the east line. So let's take a peek at what we have. 2 meters north, so I'm just going to draw a vector starting in our origin. Okay, 2. Okay, that'd be our first one. 8 meters south, so I'd go down. Again, this is not the scale. Okay, don't worry about the scale. This is just a visual representation of what a problem could look like. And then we got our third one, 4 meters 20 degrees north of west. Okay, here's the west line. We're going to go north of it 20 degrees. So here's our line. Okay, it's north of the west line by 20 degrees. Okay, there's our angle we're going to look at. Okay, 6 meters 35 degrees north of the east line. So we've got it. Here's the east line. We're going to go north of it. .35 degrees north of the east line. Takes care of that one. And then finally, 7 meters south of the west line. Okay, so what I would do with that case is draw a vector. We might go through this, but that's okay. Okay, so this one is our 20 degrees that we had before. Okay, this angle here, okay, is 25 degrees south of west. Okay, so I've drawn all the vectors in there, and I've represented them on a Cartesian plane, and we can see that this one is a true 35 degrees. Okay, but this next one is 90 plus whatever this is. But we can express it as our 20 degrees north of west. This is 25 degrees south of the west line. Okay, and then this one here is 35 degrees north of the east line. Okay, that's this one here. So this is a way to express vectors. And this is our basic way to do that on a Cartesian plane. Have a great day. We'll see you in class.